it works better because it actually highlights the ideas, right? So the main idea he's trying to highlight is that when you take a weighing, so here he's got the first weighing as 3 5s versus 3 3s, 2 2s, and a 1. Yeah, so that's the first weighing. Okay. So the thing to notice about this is it's very extreme. Okay. So 3 coins can't weigh more than 15. You understand? No matter how they're labeled. Yeah. Because they can't weigh more than 5 each. Yeah. And here 6 coins can't weigh less than this sum here because they're the smallest numbers, right? So here it's 5 plus 11. 6 is 11, yeah? So here, sorry, this is 9. 9 plus 5 is 14, yeah? So here, notice they're unequal, right? So 14 and 15 are not equal, yeah? But 14 is the smallest this can be, right? And 15 is the biggest this can be. That makes sense? That makes sense? So, and for the weighing to not automatically detect that something's wrong, the 15 should weigh more than the 14, right? So can you see if the 15 weighs more than the 14, okay? Hello? So if the 15 weighs more than the 14, okay, and this is at least 14, yeah, then these actually have to be 15. Does that make sense? Yeah? Because we know this is at least 14. For this to be more than something that's at least 14, it has to be at least 15, right? But it's also at most 15.
Yeah.
So it has to equal 15, right?
Oh.
And so if it's equal 15, then you know that they're all correctly labeled. Yeah? That makes sense? And if this is equal 15 and this is less than that, right? If it's less than 15, but this is at least 14, right? So it has to actually equal 14. It can't be 13, right? Okay. So if it's actually 14, then all of these are correctly labeled, except they might be jumbled, right? That makes sense? So what that tells you is the 3s, 2s, and 1s cannot be weighing 4s and 5s. They have to be weighing 3s, 2s, and 1s. Does that make sense? Okay, then he uses the same idea for the second weighing, okay? So now you use the 5s that weren't used before, okay? Plus the 3s. And you put them against the 1, the 2 4s, and 2 5s, yeah? That makes sense? So here you know that the 4s have to weigh at least 4. You understand? Yeah? And these 2 5s have to weigh exactly 5. We already know they weigh 5. Yeah? And the 1 has to weigh at least 1, right? So the same idea applies. So the right hand side has to weigh at least 19. Michael, you've been listening? So the right hand side has to weigh at least 19. You understand? Okay, but the left hand side has to weigh at most 19. You see? Because the 3s can only weigh less than 3. And the 5s can only weigh 5 or less, right? So if this weighs at most 19 and this weighs at least 19, and it tells you they're equal, right? Then they both have to weigh exactly 19, right? Okay, because if this weighs at least 19, well, it could weigh 20, right? But this one weighs at most 19, so this can't weigh 20 for it to be equal, right? So this can't have any of the higher possibilities, and this can't have any lower possibilities, yeah? So they actually must be equal, right? To 19, yeah? Okay. And for this to be 19, then all these have to be correctly labeled, right? Yeah? So the 2 4s are correctly labeled, the 1 is correctly labeled, yeah? Okay. And for this to be 19, the 3s have to be correctly labeled, and the 5s have to be correctly labeled, right? So the only thing that's left are the 2 2s and the 2 4s, right? But the 2 2s can't be 2 4s because you know they have to be amongst these, right? So they have to be the 2 2s. And the 2 4s can't be anything else because there's only 4s left now. Okay? So Can you see that's a pretty nice solution to a nice problem?